Hello everyone. In this lesson, we will use problem-solving flowchart to translate verbal statement into an equation, and then we solve for the simple linear equation. Many word problems can be translated into mathematical equation. Simple linear equation can be developed and quickly solved to get the accurate result. The following flowchart demonstrates certain steps to consider when solving for word problems. So step number 1 is to read the problem carefully. Then we clearly note what being asked to find. We assign variables to the unknown quantities. In this particular lesson, we are going to work with simple linear equation. So one equation and one unknown. And linear equation means that you are solving for x. And we only have one solution for this equation. So we are going to assign x as the unknown. Then we are going to translate the action words into the mathematical operations. There are 4 basic mathematical operations: addition, subtraction, multiplication, and division. Then we complete the mathematical equations. Don't forget, equal sign is the most important symbol of mathematics. Without the equal sign, we don't have an equation. We have to clearly indicate the equal sign so that we have the left-hand side equal to the right-hand side, and then from that we can solve for the unknown. We can use all the steps that we have learned in previous unit or previous lesson involving linear equation to solve for x. The very last step is to interpret the result, and when we double check the solution, we can make sure that the left-hand side equal to the right-hand side, or in this case, we should read the word problems and substitute our unknown into the equation to see if it makes sense. Alright, now let's get started. But before we continue on with the example, we should review the action words versus the mathematical operations. Okay, so if we talk about the sum of A and B, or the total of A and B, we are talking about addition. If we are talking about difference of A and B, that means we subtract. The products mean multiplication. The quotient means division. Okay, so sum is addition, difference is subtraction, product is multiplication, quotient is the division. So there are different languages here. Different wording can be used to express the same thing. So to express the sum or the total of A and B, I can say that A plus B, B is added to A, or B is more than A, and A is increased by B. Okay, so if we talk about the difference, that means A subtract B, I can say A minus B, B is subtracted from A, B is less than A, and A is decreased by B. If it's a product, that means we multiply. So A times B or B times A, or A is multiplied by B or B is multiplied by A. For the quotient, okay, we have a division here. So sometimes we can express the statement as this. Okay, the expression is A over B. Okay, I can express this as a fraction as well. So I can say A divided by B. Okay, so if you are starting with the B, then you should say B is divided into A, or A over B, A per B, or the ratio of A and B. They all represented these two divided by each other. Excuse me. Alright, so let's start with the example. Okay, so this example saying that 10 more than 6 times a number is equal to -2. Find the number. So it is helpful to read the entire sentence at once. Okay, 10 more than 6 times a number is equal to -2. So we can translate this entire sentence into a mathematical equation. So then we are going to check 10 more than. So the word more than here, the two words more than, representing the addition. Okay, 6 times. So it's representing a multiplication in this case. So you find more than as addition and then times as multiplication. So I can write the number 10. Okay, more than, it means that I have to add that with 6 times a number. So 6 times x equal to negative 2. Okay, so if you assign the number here as x, so you write 6 times x. Okay, 10 more than that. That means 10 plus that product will be equal to negative 2. So right here, okay, I assign this number as x. Then 6 times that would be 6x. 10 more than, that means 10 plus, equal to negative 2. Alright, okay. So now that I kind of present this here for everyone already, and I color coded it. Okay, so 10 more than, I put 10 plus 6 times a number, I put 6 multiplied by x is equal to, is the equal sign and negative 2. So in solving for this simple linear equation, what we need to do is we have to isolate the unknown. Isolate the unknown, I will get rid of the number 10 on this side of the equation. So I will subtract 10 on both sides. Okay, so 10 plus 6x. Then what I do is I will subtract 10 here. And I subtract 10 here as well. Okay, so now you see that 10 and that 10 cancel out. I have 6x equal to negative 12. Okay, so in order for me to get rid of 6, I will divide both sides by 6. Okay, so this 6 and 6 gone. I have x equal to negative 2. Okay, so let's double check. Okay, so if I take negative 2, I multiply by 6. What do I get? I got negative 12. Negative 12 plus 10 here, I have it equal to negative 2. Okay, so it makes sense. So in the end, we can say that 10 more than 6 times negative 2 is equal to negative 2. Alright, for the next example, we have 11 less than a quotient of a number and negative 5 is equal to negative 3. 11 less than, so the word less than representing the subtraction. Okay, so right here we can say less than is the subtraction and the quotient is the division. But we have to be careful about the order of the operation that we have right here. Okay, 11 less than a quotient, less than here, that means it will come after this statement, a quotient of a number. So that number is x, right? So that number is x. A quotient of a number and negative 5, so that means I'm talking about x divided by negative 5. Okay, and 11 less than this quotient. That means I have to place the subtract 11 after this. And it's equal to negative 3. So now you can see that I translated here into the mathematical equation for everyone, color coded, a quotient of a number and negative 5. Okay, 11 less than this quotient of a number and negative 5. So therefore, I have to write x divided by negative 5, then subtract 11 equal to negative 3. Alright. Okay, so then what we need to do next is we just have to solve for this equation. So I have x divided by negative 5, subtract 11 equal to negative 3. So what I need to do is I need to add 11 to both sides so that I can get rid of the 11. Okay, so now what I have left is I have x divided by negative 5 equal to positive 8. Okay, so what I have to do next is I have to multiply both sides by negative 5. Okay, so that cancel with that. I have x equal to negative 40 as the result here. So let's double check. Okay. Okay, so if you take negative 40, you divide it by negative 5, you should get positive 8. Then positive 8 subtract 11 give you negative 3. So it really do make sense in this case. Alright, so let's continue on. What I'm going to do is I will complete all of this exercise for everyone, because I realized that the word problems translate into mathematical equation could be a bit challenging. Okay, so now we are talking about the product of a number and negative 6. Whenever we talk about product, it means we multiply. So that number is x, okay? So product of this x and negative 6 is equal to 42. So I'm going to put negative 6x equal to 42. So I take negative 6 multiplied by x. You see? Okay, now divide both sides by negative 6. I should have x equal to negative 7. Okay, so let's double check here. If you take negative 7, you multiply by 6, what do you get? Okay, so in this case, you don't multiply by 6, you multiply by negative 6. Okay, so negative 7 multiplied by negative 6, you get positive 42. So it's quite true. Alright. Okay, so a quotient of a number and negative 9 is equal to negative 3. So that means we are going to have a quotient of a number. That means we divide. Okay, so a quotient of a number, we divide. Okay, so x divided by negative 9 is equal to negative 3. Okay, so it's just a straight translation from the word problems to this mathematical equation, because we only have one operation here, so it's simple enough. So right here we also have one operation, but when there's two or more operations involved, then we have to be very careful. Okay, so in solving for this, I will multiply both sides by negative 9. Okay, excuse me. Okay, we multiply both sides by negative 9. And now you see that this one and this one cancel. So what I have left is x is equal to positive 27. Alright, okay. So when x equal to positive 27, I will say a quotient of 27 and negative 9 is equal to negative 3, which is quite true. You take negative 7, negative 9 divide into positive 27 is equal to negative 3. Okay, so I want everyone to review the action words here and how we can translate them into the mathematical operations. Alright, so let's continue with the next question. The sum of a number, so that means we are talking about addition, right? So the sum of a number and 12 is equal to negative 7, so this number is x and 12 is equal to negative 7, so the sum means that I have take x plus 12 will be equal to negative 7. Alright, so now I'm going to subtract 12 to both sides to isolate the x. Okay, x is equal to negative 19. Okay, so the sum of negative 19 and 12 is equal to negative 7. So it's actually quite true. Okay, so in the end, we should read the word problems one more time with the solution that we found to see if it actually makes sense. Okay? If you take negative 19, you add that with 12, it should be equal to negative 7. Okay. So let's continue to the next one. This one said that the difference of a number and negative 5 is equal to 15. The difference of a number and negative 5. So difference here, that means you have to subtract. Okay, so it is a subtract. So if we have that number as x, so the difference, so I would say x subtract. Okay, x subtract a difference of a number, so that means x subtract something, and negative 5, so here's negative 5, then I should put negative 5 in the bracket to make sure that it separate this, so that you know that this combined with this will make it a plus. Okay, is equal to 15, so equal to 15. So in this case, x plus 5 should be equal to 15, and then I subtract 5 on both sides, so x is equal to 10 in this case. Alright, okay, so the difference of 10 and negative 5 is equal to 15. Yeah, a difference of 10, so 10 subtract negative 10 becomes 10 plus 5 equal to 15. I'm sorry, I should say that the difference of 10 and negative 5, so that means 10 subtract negative 5 is equal to 15, right? So that means 10 plus 5 will be equal to 15. Okay, what about number 5? So this is very much similar to the example that we just did. We have 20 more than 7 times a number. So now you can see more than should be addition, right? And 20 more than, I can put 20 more than 7 times a number. So 7 times x will be equal to 41. So a straight translation from the word problem into the mathematical equation. 20 more than, that means 20 plus 7 times, that means 7x is equal to 41. And then I can go ahead and solve for this. Okay, so I think I should make a different color here. Excuse me, I just want to rewrite it just to be consistent with my color. Okay, so we have plus 7, here's 20, that means I subtract the 20 here, and I use this and that egg gone, so I have 7x equal to 21. Divide both sides by 7. Okay, so get rid of the 7. In the end, I isolate the x, and x is equal to 3. Okay, so now we will put 3 into this sentence to see if it makes sense. Okay, 20 more than 7 times 3 is equal to 41. So 7 times 3 is 21. 20 plus 21 equal to 41. Alright. Okay. So for number 6, 10 less than a quotient. 10 less than, that means you have to subtract the 10. So subtract the 10. Okay. A quotient of a number and negative 2. So quotient, that means you have to divide. Okay, so in this case, it's x divided by negative 2. So I will take that and put that in here. X divided by negative 2. Subtract 10 equal to a negative 27. Okay? Yeah. So let me rearrange this so that it's alright. Okay, so in solving for this, I will add 10 to both sides. So this and that cancel out. Okay, so just keep the same color this time. Or maybe I should just make sure that I subtract 10. I plus 10 on both sides. Okay, then I get rid of that. Okay, now I will have x divided -2 will be equal to -17. Okay, so the next step is to divide. So I need to multiply -2 on both sides. So this will give it a x isolating on this side of the equation, and -17 times -2 will give me positive 34. Okay, so let's double check here. If I take 34, I divide it by -2, I should get -17. -17 subtract 10, I should have -27. Okay, so 10 less than quotients of 34 and -2 is equal to -27. Alright, so the main concerns for this lesson is to make sure that we understand all these languages, the different types of expressing some different types of sentences expressing the difference, the product, and the quotient. Okay, so I think it's actually listed here for everyone, so it should be very clear in working with this lesson, and then working with the problems that I assign for everyone. And I believe that I have plenty of questions for this for you to work on for the online assignments. All right. Thank you, everyone.